Now, in this video, we will be talking about solar cell. Solar cell. We also call it photovoltaic device. Now, what is this solar cell? It's a special PN junction, no doubt about that, which converts solar energy that comes from sun into the electrical energy. And this PN junction is referred as solar cell or photovoltaic device. Now, let me draw this solar cell. What it has now this is P region, this is N region, and the light falls on this junction, and then here we have metallic contacts, and this is probably the junction, right? So here we have this. This is nickel plate, right? And then from here we take a contact and we connect it with the external resistance R. Can have a key here. So this is my load resistance. Now the point is that if we talk about a simple solar cell, it consists of a PN junction as I have drawn here. In this you can see that N region is very thin and P region is very thick, right? Now, if I have to compare the thickness of these two regions, I mean, if N region has the length, has the breadth, I should say here, as 0.3 micrometers, then the P region must have nearly the height of 300 micrometers, right? Okay, so micro, you understand, this is 0.3 into the 10 to the power of minus 6 meters, and this is 300 times 10 to the power of minus 6 meters. And as I said, the outer regions of this PN junction, they are plated with a pure metal, and these metallic contacts are connected to the external load known as load resistance. Now, if we have to be symbolic about it, we have a PN junction, okay, and we develop energy from them by virtue of the light that falls on the junction of this PN junction. And materials that are used because they have commercial viability, they are the need of the society, they are the need of every society living in this world, right? So there has to have certain things which have to be kept in mind while manufacturing such kind of devices, right? So to be precise, the material that we use should be low cost, right, and should be easily available, right, and the conductivity should be desirable conductivity, right? Optical absorption, that means the absorption of the energy that's coming from the sun it should be very large. I mean, it should be high. It should be like nearly 10 to the power of 4 to 10 to the power of 5 per centimeter. And and another important thing is the band gap, because every PN junction cannot behave as a solar cell. So you have to have precise forbidden energy band gap, and it can the band gap in this case can range. It can range from 1 electron volt to 1.8 electron volt. Now, talking about the action of this solar cell, how does the action takes place? Now, what happens basically when solar energy or light energy, it falls on the solar cell, we have what we have is we have electron hole pairs, and these electron hole pairs are generated in both N region as well as P region of the junction diode. Now, the electrons from P region, okay, diffuse through the junction to N region due to the electric field across the depletion layer by the electric field that's set up due to the barrier potential. Okay, thus the holes and electrons are separated out. They are separated out, or I can say that the electric field due to the barrier potential causes their separation. Now, for better separation of electrons and holes under the effect of junction field, it is required to have photoemission. So what's happening here is that the photoemission takes place in the junction area only, right? So this thing happens here. Now, if the PN junction diode is open, I mean there is this key is open, then it's open circuited. Then holes and electrons will collect. They will collect. Okay. They will collect or accumulate on the two sides of the junction. So they will accumulate here. So this will give rise to an open circuit voltage. Okay, so this is going to give